Assalamualaikum and hello. In this video, I'm going to focus about order of reaction and also about units for the rate constant. If you want to determine the order of reaction based on the experimental data, you have to consider, for example, I got this expression, reactant A to produce the product. When we want to write the rate law, you have to write based on concentration of reactants. So in general, I got rate equals to K times with concentration my reactant A raised up to power X. So X is my order of reaction. So your order of reaction is the value. I'm going to start with X equals to 0 first. So this reaction is considered as 0 order with respect to A. So I'm going to replace the value for X with 0 in my rate law expression. So rate equals to K. So the conclusion, we know that rate is independent of concentration A. And if I ask you to determine the units for that, the units for rate constant is just equals to the units for rate. Next one, I got the next value for X equals to 1. So I know that rate equals to K times with concentration A to the power of 1. So saya dah ganti sekarang. And what I know from here, this reaction is first order with respect to A. What's next? I assume the initial concentration for A is equals to 1.0. So if I put the value in my rate law expression, and I will have the expression like this. And if concentration of A is doubled from 1.0 molar to 2.0 molar, so my second rate, rate 2 equals to K2 times 1.0 sebab dia double. So you can see from here, is going to be 2K times with 1.0 molar. Hence, my second rate is going to be 2K times concentration of A. So, as you see from here, rate 2 is equals to double of rate 1. So, that's why nilai dia akan double. So, my conclusion I can say from here, if concentration A is double, the rate of reaction also double. Next one, I got another case. If my X equals to 2, so inserting this value into the rate law is going to be 2 as my raised up to power, and I will consider this reaction is second order with respect to A. And next one, I assume my initial concentration A is 1.0. So I put the rate 1, so this is for rate 1, equals to K times 1.0 molar to the power of 2. So if concentration A is double to 2.0 molar, so I got the next one, rate 2 equals to K times with 2 times 1.0 molar to the power of 2. So as you see from here, kita akan keluarkan kita punya punca kuasa. So you will have like this one. And 2 to the power of 2 is 4. So my value is going to be 4K. Hence, what can you say from here? Rate 2 equals to 4K times with concentration to the power of 2. And what can you illustrate from here? Rate 2 equals to 4 times of rate 1, which is this one. So, my conclusion, I can say that when you double the concentration of A, the rate will also increase by a factor of 4. So, please be careful because there are a lot of mathematics here. So the next one, you can also determine the order of reaction from this experimental data by analyzing the changes in concentration of reactant and their rate. So for example, I got the reactant where my concentration for that reactant varies. I put any amount of it. So what will happen to the change in rate? It will remain unchanged. That's why the order of the reaction will be zero order. Next one, kalau saya letak concentration double, so what will happen to the change in rate? It will be double as well. And the order of the reaction will be first order reaction. If you double the concentration, so the change in rate will be increased 4 times. So this is going to be the second order of reaction. So depending on which amount of concentration for the reactant you got from the question, you have to know what change in their rate and what is their order of reaction. So let's try one example. The rate of reaction increases 8-fold when the concentration of one of the reactants is double. Determine the order of the reaction with respect to that reactant. So I got my rate law expression. So I got the reactant is A. So when A is double, rate increases 8-fold based on this statement. So what's next? You can say that 8-fold of your rate equals to K times with double of concentration of A to the power of A. So the A here is the unknown that we want to find out its value. So when you rearrange, you can get your expression in this form. And what's next? You got 8R equals to 2AR. Here, I replace the expression for R equals to K times concentration A to the power of A. And what's next? I'm going to rearrange based on the knowledge that I've learned in indices. We know that from here, 8 equals to 2 to the power of 3. So I can know that A is equals to 3. Thus, the order of the reaction is 3. So that's how you answer this example. Settle for the order of the reaction. The next one, I'm going to focus the units for each order of reaction. So we know that reactant A produced the products. So you got the expression for the rate law. If this case is zero order reaction, how you want to determine the units for your rate constant? So you will put the x equals to 0 from here to here, and you will have anything to the power of 0 equals to 1. So rate equals to k. So unit for k is equals to the unit of rate. So usually unit untuk rate adalah concentration over time. So that's why you will have molar over time. So that is the units for zero order reaction. Let's continue with the first order reaction. I'm going to replace x with 1. So rearrange my equation. K is my subject. I will have rate over concentration A. And if you put the unit into the expression, you will have the rate is molar per time over molar for the concentration. So you will cancel out the molar. You will got over time left. So this is going to be the units for K rate constant of first order reaction. Now we go to second order reaction. I'm going to replace X as 2. So rearrange K as my subject. I will have in this form where unit for K is equals to molar per time for rate, and then concentration to the power of 2 for A2 here. And then you cancel out M with 1 of M from below. So what's left is equals to per molar per time. So this is the units for rate constant of second order reaction. So what can you conclude from here? The order of reaction can also be determined by looking at the units of K. So please remember, these are the units for K based on different order of reaction. And I hope you clear the time can be in second, minute, or hour. I leave it to you. Try this 6.0 for your exercise. Please try to do this one because you can practice to do differential rate equation, order of reaction, and also the rate constant based on this example. So try to do this. So that's all for this video because I just want to emphasize a few tips and key points, especially about order of reaction and rate constant, depending on the rate law expression. So I hope you are clear until this point. I'll see you in the next video. Bye!